Hi.
Quiz 3, but only 2 questions I got stuck on. So I didn't write the questions down.
Okay. Let me see if I can look for your quiz. Hold on. Okay, quiz 3. Okay. Okay. So, where are you? There you are. I'm going to share the screen, okay?
Okay, it was the pre-quiz, not the quiz. I got 18.5 out of 20 on the quiz.
Right. Okay, so the pre-quiz.
Yeah, there was 2 I got wrong, and I kept redoing them, and I was trying to figure out, I was getting slightly off.
Okay, so then hold on. Let me look for the pre-quiz then. Hold on.
I was trying to find the papers where I took when I wrote the questions on them. But I think this is my questions, my work from the quiz and not the pre-quiz.
Okay, so pre-assess. No, you got you got it all right. You got 5 points.
Yeah, but that's because they're unlimited attempts.
Oh, you don't understand. I got you.
Yeah, it was the one about, I don't know. Maybe if you share your screen, I can
Yep, I'm gonna do it right now. Hold on.
Okay, thank you.
Yeah, it was the one asking you about the number of molecules.
That one, and then there was one other that I guessed on. I did the work and I didn't get any of the answers, and I guessed on it and I still got it right. And the answer for I know was like 77 or 77.5, and that's the one I guessed, but I just guessed the right answer.
Let me share. Okay. Okay, so let's do the one that you got a 0 on.
The reason I got the 1.67,
okay.
but I got 10 to the 20, like I got a different exponent.
Okay,
But,
so what did you do?
let's just try to find my papers. I keep them all in the same folder.
It's okay, you don't need your papers. You're smart.
Okay.
Look at it and tell me what you did.
I believe
Hi, Justin.
Formula. So I took the C9. Hello?
Yep. You took the C9H804.
Yeah, and then I multiplied it by the molar mass.
Okay.
No. I didn't do that. Sorry. I started with the 500 milligram tablet.
Okay.
And then I took 500 mgs and converted that to grams.
Okay.
Once I got to grams, I used the formula of it to get out of grams with the molar mass. And I had moles, and I went from moles to Avogadro's number.
Yeah, that's how you do it. Then you didn't put something in your calculator right, or you didn't add something right.
Okay.
That's how you do it.
And then the other one, where is it? The one that was that one, number 5. I checked it like 4 times and I still was like, I don't know why I'm not getting the right answer. I didn't get 77. My answer was like 30 or something, but I just picked, my answer wasn't close to any of the answer choices, so I just picked one, but 77.5 ended up being right.
Okay. So calculate the mass of excess reagent remaining at the end of the reaction, which 90 grams. Okay, so you had to figure out which one was who's the excess there?
And I used the 90 grams of SO2 and I took that to the SO3, and then I used the 100 grams of O2 and converted that to the SO2.
Okay.
And I got an answer, but I wasn't getting.
No, but that's not the excess. That's the first step. That's figuring out who's the limiting reagent.
Oh.
Yeah, taking the reactants to the product that's how you figure out who the limiting reagent is.
And then then don't you subtract the excess minus the reagent?
No, you don't do that. Yeah, no. Because it's not the same person.
Oh, no. Don't you find the excess reagent and convert it to grams, right?
Yeah, but hold on. You take both reactants and go with the product, and that tells you who is limiting reagent. So do you remember who it was? SO2 or O2?
No, I can do it really quickly.
It doesn't matter. It doesn't matter. So let's say it's SO2, right? So then you would take that number that you got for SO3 from SO2, right? Like that number, the product number, and then you would take that back dimensional analysis to the excess reagent, to the O2.
Oh, I remember this is the one like we were doing in the study session with Jalen, right?
Yeah.
Kind of.
Yeah.
Okay.
And then once you get that answer,
you subtract it minus the limiting.
Then subtract it. Yes.
Okay, I understand. So I did do it wrong.
Yeah.
But okay, we're gonna finish that problem tomorrow between 12 and 1, he said.
Okay. All right. Anything else? If not, I'm gonna ask Justin to see if he has any questions.
He can go first.
Okay. Hey Justin, what's up?
No, I don't have any questions really.
No?
At least not yet.
Okay. All right. Well, you have the floor then. Elijah Cintron.
That's him. I'm using his phone.
Hi.
Okay, so I started working on some stuff for chapter 4.
Okay.
I put it down. Oh, it's over here. And I have some questions. I know this isn't on our what's it called? Our study goals, but I just wanted to know. So for in the book, chapter 4.13.
Yeah, I'm listening.
It was asking how you're supposed to, like, it was giving you compounds and you're supposed to tell if it was electronegative or not, and then you're supposed to tell if it was strong or weak. And I know that to tell if it's electronegative or not, if it's electronegative, I know that it completely dissociates.
Okay, you're talking about electrolyte or non-electrolyte, not
electrolyte. Yeah.
Okay.
And I know, like, you can tell if it is by looking at like the little pictures they give you in the book. If it's completely dissociated, it's usually an electrolyte, and if it doesn't dissociate, then it's not an electrolyte. But they were giving compounds like in words and not like pictures with molecules, and it was saying to say whether it was weak, strong, or non-electrolyte, and I wasn't exactly sure how to go about doing that. I read the section, but I just kind of don't get it.
Okay, so what number were you doing?
413 and 4.413 is like the conceptual question where it asks how you do it, and 4.10 is like giving actual examples and wants you to find the answer.
Okay, so I think mine is 4.9. Is it identify each of the following substances as a strong, weak, or non?
Yes.
Okay. And you're saying that you didn't understand it because all the ones that, okay, so the examples that I have are water, right? Potassium chloride, um, nitric acid, and acetic acid. Does that sound familiar or no?
Yeah, but I just didn't know how do you decipher if it's strong, weak, or.
Well, exactly the answer that you gave me. So if it breaks up into, if you look at the solubility
Oh,
chart,
oh,
you use a solubility chart for that, right?
okay.
For example, acetic acid is maybe the one that you probably wouldn't have known as much, but they give it to you in the book, right? They tell you that that's a weak one because it doesn't like completely dissociate. So, but everybody else, KCl, HNO3, those are electrolytes or strong electrolytes, and water is not because water is water.
Yeah.
So and then the other one, there's one more. It's part E. I just saw it, and that is C12H22O11. I wouldn't expect you to know that, but that is
It's not because it's a sugar, right?
right. It's an organic compound, exactly. So yeah, exactly.
I just remember you saying that in class, and I know that it's a multiple of C6H2O6.
Exactly. I mean, and water, if you really want to get technical, water is, remember, I think I've said it in class too, water doesn't live as water. Water doesn't live as H2O. Water lives as H3
Yeah,
plus.
there was a question in the book, not about that, but it was asking like, if 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 water is a non-electrolyte, then why do you have to be careful touching electrical things with wet hands? And isn't it because like water isn't just water? It usually has minerals from like the tap and stuff in it.
Well, that too, but it also has a charge because it sits as hydronium, so H3O plus. So it does have a charge. It tends to like form H3O plus within water itself. So if you want to get technical, it is a very, very weak electrolyte, super weak electrolyte. But yeah, those are like, so the sugar and the water is the only one that would be non-electrolyte, very, very weak electrolyte.
Okay, that
And
makes
the
sense.
acetic acid, sorry, yeah, and the acetic acid, which is a weak acid.
And then, I don't know if anybody else? I don't know who's all here.
No, it's only Justin.
Oh, okay.
And he doesn't have any questions, so.
My questions tend to be more conceptual also and not on the study goals, so I don't want to get in the way of her answering questions that would actually be on the test.
It's okay, you could go. I'm
Um,
just getting it together.
so I have a question about water being amphoteric. So when in the presence of a strong base or a strong acid, it can act as either a very weak base or a very weak acid in order to, well, that's as far as I read.
Oh, so.
But that's what I was saying. I was trying to figure out a question where that would make sense, but is my understanding so far correct?
Yes, so what does amphoteric mean? Do you
It
know
means it
that?
can act as either a base or acid.
That's right. So, and water is one of those compounds. It depending on who you're reacting it with, it can either act as the base or the acid because it has the H plus and the OH. So that's why it's considered an amphoteric compound. But that Justin, I'm not going to ask you about that in our exam. So don't stress too much about it. But I'm really glad that you know that because that's more of a Chem2 type question. That's really dealing with bases and acids, like really dealing with bases and acids.
Okay, and then I only have one small follow-up. So, I don't remember if this was on the study goals or not, but will we be required to be able to compute the pH and the pOH of
No,
us? Okay.
no. Again, that is Chem2. That's the negative log of H plus and the negative log of OH minus. That's negative. That's Chem2 stuff and quant stuff, not your class stuff. So yeah, don't worry about that.
I have another question.
Okay.
So I don't remember the problem. I was supposed to do it. I'm not gonna lie, I didn't end up doing it. That problem that you said you were assigning us homework and we were gonna go over in class, but we never got. It was like 137 or 3.27, and it was the one that you said should have been an easy question.
Oh,
Parts
And
per
you said it's
million.
a one-step problem.
Are you
And we
talking about
talked
the
about
parts
it
per
a little
million?
bit.
which one, Justin? Do you
I
remember?
think she's talking about the parts per million question. You said that's usually used reserved
No,
for.
no, no, no. It was a question. It was like something, and if you take 50% of it,
Oh yeah, I do remember that one.
I wanted to just go ahead and go through it. And I know you're
Oh
saying it's like
man, hold on, because I gotta look for it. I don't even remember. I do remember it was in excess of 50% or something like that.
yeah, but it wasn't an excess. You told me it wasn't a limiting reagent question or a theoretical
Yeah, it
yield question.
Oh,
But I was just
hold on.
stuck.
You gotta give me a second then, because I don't know where that is. Okay, I think I found it. It's 3.137. So
Yes.
you have the book. Do both of you guys have the book?
I have the digital version, which I did not know you can't use without internet, which is why I'm on
Oh,
on his phone. I don't have
Oh,
internet.
okay, so then I have to.
well, I have the PDF. I could send it to you.
Oh,
But
I
yes.
tried to use the PDF, but through the bookstore they were like, you have to use this website.
Oh no, I mean the PDF, like the offline PDF.
Please do. I'd
Uh,
appreciate it.
your name is Chloe, right?
Yeah, Chloe Adams White.
Okay.
Thank you. It's so
Okay.
helpful.
Yeah. So if you can see if you get it, because that way I don't have to write the whole thing, because it's
Okay.
it's all like a whole reaction and stuff. And let me read it now so while you're waiting, the following reaction. Okay, metric is written. Often carried out using excess of
Under contact hours, clinical hours. With a licensed veterinarian, all types of experiences are accepted, including but not limited to pain experience, shadowing, and etc. Long as it's clinical,
yeah,
not
super easy.
sitting or pet watching.
Wasn't it a continuation of a part one?
No,
No, it's its own problem.
yeah, it's his own problem. So, do you have it yet? If not, I'll start.
I'm trying to. I can probably go back to it. I'm connecting to my hotspot right now, so I can try to change the page.
Am I sharing? Do you see the screen?
I see the notebook. Yes.
The notebook. Yeah. Okay. Okay. So I'll just start writing the reaction. C4 H9Cl plus.
Places they won't allow you in. You have to knock on doors because whatever field you're trying to go into, you have to show some kind of stick to itness. You have to make sure that you are knocking on doors, being persistent, and trying to get in there and get some of that experience because it will
Okay.
make it work.
So it's a paragraph, so you gotta listen. So it says the following reaction is stoichiometric as written, and then that's the reaction. It's balanced, I'm assuming. Yeah, it's balanced. But it is often carried out with an excess NaOC2H5. So this guy is your excess reagent, and this guy is obviously your limiting reagent. If the reaction shown was carried out with 6.83 grams, so this guy, 6.83 grams of that guy, how many grams of this guy would be needed to have a 50% molar excess of that reactant? So how many grams do I need to have a 50%, a greater 50% molar excess? That was it, right? That was the question? Do you remember?
Yes.
Yeah,
Yes,
so
that was.
basically, all they do is they give you, it's not a limiting reagent problem because they tell you who it is, they tell you who the limiting reagent is, and then they tell you, I start out with 6.83, but how many, if I start out with 6.83 grams of this guy, how many grams of this guy do I need if I'm gonna have a 50% excess of that guy to begin with?
So would you just convert the C4H9Cl to the NaO?
Yes, that's it.
C25, and then whatever you get, multiply it by 0.5.
Not 0.5. 0.5 is 50%. Is not, it's not in excess of 50%.
Oh,
Inputting your grades.
It'll be
then what do we?
1.5.
Right, it would be
Oh,
1.5. You'd multiply
okay.
whatever you get from converting this, once you convert that to that, whatever, C4 to Na, then you convert that answer times 1.5, and that'll be your total grams.
And then your mole ratio would be 1:1, right? 1C4H9Cl over
Right.
1.
Assuming this thing is balanced, which I think it is, but yeah, it would be 1-to-1.
Okay.
Because some people are on
So literally,
Okay.
you would convert this to moles. That's all you got to do is convert that to moles, and then you'll have the same number of moles
Okay.
for that, and then convert it to grams, and whatever grams, then multiply times 1.5.
Okay.
So the thing
Yeah,
is,
it's
don't
super easy.
last
Super
second
easy question.
prepared to get everything that you need done early.
What?
Chloe, are you by any chance in group me?
Yes.
Oh, her. I'm like, me?
Yeah, because the attachment is too large to send over email. So I'm gonna try to find you on group me.
Okay.
That our office
Sounds good. Thank you.
requires you to turn in.
I do have one very small. It's not a. It's a question of preference. But since molarity is measured as moles of solute over 1 liter of solvent, but it's also true that it's
Actually, that's not right. It's moles of solute over liters of solution.
Does it have to be 1 liter or it's any amount of liters?
It's 1 liter. The definition of molarity is per liter.
I said that, so we got one of our questions wrong on our poll goal because we were debating about it. And she said it's just liters. It doesn't have to be 1 liter. And I said, I think it has to be 1 liter. And she was like, no, it's just liters.
Well, if you guys are saying the same thing. Because if she just
No.
says liters, it's just.
We left it as 0.5 liter, like over divided by 0.5 liter. And I was like, I think we need to multiply it by 2 so it's divided by 1.
Okay, wait, what was the question asking for? Molarity?
Yes. And we had something moles divided by 0.5 liter.
It depends what the question was asking, because remember, were you taking 0.5, were you taking 500 mils out of that, or the concentration was you had that many moles and then you divided it by that many, you had that much solution.
Yeah, that was our final answer. Like that was what we got as our final answer after we finished the question. And I was like, I think we have to multiply by 2 to get it to 1 liter.
No.
You can leave it as 0.5.
You would take the moles and divide it by the 0.5 to get a molarity.
Oh.
Wait.
Wait.
Does that make sense?
I thought it was.
Pogo, what is the molarity Pogo?
Yeah.
Okay. Hold on. Justin, were you saying something?
Yeah, I'm sorry. I cut you off, Justin.
No, it's fine. My question was, can we use millimoles over milliliters?
Sure. That is, if the question asks for that, it's a derivative of molarity, but the definition of molarity is moles per liter. But if the question asks, can you give me the molarity in millimoles per milliliter, then you do that.
The reason I ask is because it's just like you said, it's a derivative of moles over liter. So at the end, the molarity ends up being the same if you follow all the steps.
Exactly. It's just the relationship between those are the same. So yeah.
I just wanted to ask.
Matter. It's just what matters is the units, So if someone asks for specific units, then you give those units. Okay, hold on. So you were doing the molarity Pogo. Okay.
If you wanted, never mind.
So what question was it? Because I don't.
Hold on. Let me check the one we turned in, and I can tell you. But it wasn't like we were having trouble with the question. We were just having trouble like shit. Like I guess the notation, I guess, is how you would phrase it.
I mean, I don't understand why you would multiply it times 2, because you kept saying that you would multiply it times 2. So I don't.
Because you were saying that molarity is moles per liter.
Right.
And so isn't it the number of moles divided by 1 liter, just like miles is miles per hour?
Right, but the fact that you only have 0.5 liters, you would divide the moles into 0.5 liters. It's the unit, right? It's however much solution you have. So if
Okay.
you just happen to have 500 mils, which is 0.5 liters, and that's all you got. But the number that you give is in moles with the
Per
unit
liter.
moles per liter, right?
So to finish the problem, we should have divided our number of moles by 0.5.
Of course, if that's what it was
Okay.
asking. It was asking, give me the molarity of this many moles in that much solution. Yeah, yeah.
Okay, I understand now.
Yeah. Well, good, because I couldn't find the stupid.
Wait, that confused me.
Okay.
The question, not the concept. I know what molarity is, but are you saying that when calculating molarity, you have to take whatever volume of solution that it is and scale that to 1 liter?
Are you
That's what I was
or
asking, but you
her?
don't.
Sorry, are you asking me or are you asking her?
I'm asking her.
That's what I was asking, but she explained that I had it confused. It's like the unit is moles per liter. Like that's how you would write it when you're done. Like that's like like if you have 1 cup, like it's like 1 cup. Like you put the cup at the end.
So
So
if
to
I
find
have 5 moles of something, but I only have 2 liters, right? And I put the 5 moles and I put it in the 2 liters, then I would, to get the molarity, I would divide 5 by 2. So I would have 2.5.
so you would have 2.5 moles per liter, right?
Right, which is 2.5 molar. Yeah.
I get it. I'm not confused anymore. I'm good.
Okay, I'm gonna just pretend I didn't hear what was said because I understood it until I heard that, but now I'm acting like I didn't hear it. But I understand.
Okay, good. Good. What other questions do you have?
And then they also program, we just got to talking about and how it's hard in environments, especially through this COVID time. They have a decap program, which is a volunteer.
So any questions on precipitations? What we did today?
I was doing some practice with them. I think I was doing them right. That's what I was doing when you first picked up. And I asked you a question. I don't remember what I asked you, but you answered it.
Okay. Great.
But I've done like a few. I was on my 3rd one.
And they're really easy.
And they're easy, and I understand the concept. In class, I just kept making small mistakes with like naming and stuff, so I've been trying to practice my naming. But I think I know like the formulas for my polyatomics. I think I just need to really make sure that I know the charges, because that's why I was making mistakes earlier. Was I was messing up the charges.
You said the sulfate was sulfite. You said sulfate was
Sulfate is 2 minus.
Mm-hmm.
Sulfite is SO3 2 minus, right? And then hyposulfite is SO2 2 minus.
Correct.
Okay. I did a review after class because I was like, I kept messing them up, but I'm going to review them more before the test, obviously.
Yep.
But, and then I remember that you have to balance before you can move to ionic or net ionic, because I was making that mistake too.
Right. What's up, Justin?
Oh, I was gonna ask, what method do you use to remember the polyatomic anions?
Me?
No, her.
Oh, okay.
Well, I know that all of them, but a lot of the 8s are O3. So I use that. Obviously I've been studying them, but I use like chlorate is one. I don't know why, but it's super easy for me. And then on the periodic table, I know that these ones like fluorate, chlorate. Huh?
Look at the board.
The board.
Yeah, the thing, the screen.
Oh yeah, those. But also when I was talking to Dr. Tournay, she was saying like on the test, one of them was asking about bromate, and I didn't study that one. I studied I studied what's the CO3 carbonate. I studied bicarbonate, and I had originally wrote down bicarbonate, but I was like, that's not bromate. So then when we talked about it, all the ones in the halogen column have a -1 charge. So like chlorate is ClO whatever, or ClO3 technically, because if it's 8, but then it has a -1 charge, and bromate is still in the halogens column, so it has a -1 charge, and iodate also has a -1 charge. So when she told me that, that helped me get the relationship with a lot of those. I ended up guessing on the test, but I got it right, and then I checked after. But and then I know that
I don't think you've told them your method.
No, well,
Oh.
I was gonna say that sounds complicated, but there's a saying that you can remember that has most of them, or at least the important ones. So the saying is, I'm trying to find the screenshot that I had of it, but I can't find it. But the saying is, Nick, the baby camel, ate an inch clam and crepes for supper in Phoenix. Yes,
Oh
that
my
sounds complicated, but it's
God.
not. It's not, because the number of consonants in the word is the number of oxygens, and the number of vowels is the charge on the.
Sir, I don't know what consonants or vowels are.
Yes, you do. Yes, you do.
So, for
Don't.
example, the first word, Nick, it has 3 consonants and has 1 vowel, so it'd be NO3 minus. And then bromate, it will be baby, Nick the baby, camel, so it will be,
2 consonants, two,
yeah,
two vowels.
wait, that was the one, because it depends on whether or not you count Y as a consonant or not. But it works. I have to find the screenshot. I'll send it to you, because.
Okay, thanks. But that's you know how you said what I was saying was complicated? To me, what you just said is complicated.
And that's why
Okay.
there's different colors in the coloring box. Everybody does their own thing.
And what else? Do you have any? Oh, can you explain to me again? This is from exam 1, and I didn't get to put it in because I ran out of time. But okay, so I know that hydration with like the electrolyte thing is when the atoms, the hydrogen atoms, surround the ion in a certain arrangement because of the charge, like because oxygen is electronegative, and so it pulls some of hydrogen's electrons closer to itself, and it makes it slightly negative, and then the hydrogens are slightly positive, and then the ions are positive or negative, so it flips in or flips out depending on the charge. I know that, and I get that, and I get that's what hydration is, but I don't really understand the difference between hydration and a hydrate, or like when a hydrate is attached to a compound.
No, so that
Or
is what
is it
hydrate
the same
does.
thing?
The hydrate,
Oh, I didn't know that.
the hydrate, when you have something like a copper sulfate heptahydrate, like what I wrote on the board, it's basically a crystal structure. It's like a crystal structure where you have all of these coordinated water molecules attracted to the copper sulfate because of what you just said.
But I thought the copper sulfate is neutral. Are you?
Of course,
Because I thought the salt
it
isn't
is.
in water.
Of course it is, but it still has electronegativity.
Oh.
It still has all of that stuff. It still has polarity. Absolutely. So it's still the hydrogens from the and the oxygens from the water are still attracted. It's not
Okay.
like like I guess it's not on
Is
ionic.
that why salts absorb water out of the air?
Probably.
Oh.
Chemistry, science.
Okay, that makes sense. So they basically, they are the same thing. A hydrate is just not in, like when something's immersed in water, but hydration is when something is in like a water solution.
Exactly.
Oh.
Exactly. So
Okay.
SO4 is a compound like this. Actually, I think it's 2468. I think it's actually all double bonds, right? So you have, and then you have the copper around here because it's attracted, right, to the SO4 2 minus. We'll talk about later why it's a 2 minus. That's electronic configurations. But still, this is very electronegative. The polarity is going towards this way, towards the oxygen. So you have all these hydrogens, right? All these hydrogens from the water
Connecting to each
well,
oxygen.
not connecting, but like hydrogen bonding, right? Like they
Yeah.
be attracted to the oxygen. So you have like all this coordination going on. So that's what a hydrate is basically.
Oh. Okay. Okay, and I have another question then.
Okay.
Can you explain, like, okay, so I get I don't know how to pronounce it, but the one that starts with a B, I understand the concept of those acids and bases. It starts with a B, hold on, let me check my notes.
Oh, what?
It's
Bromstead?
what'd you say?
The Bromstead-Lowry acids and
Yes.
bases?
Yes, I understand the what did you say, Bronsted?
Yeah, it's Bronsted-Lowry. It's just a different way to describe an acid.
Okay, but I was just gonna ask, can you explain acids and bases in general? Because I could tell you the definition of a base, or I could look and tell you like if it has more H plus, then it's an acid, and if it has more OH, then it's a base. But I really don't know what's going on. I can just spit out the definition. So I was just wondering if you could like explain it to me more, because I feel like I don't get it. Like I know an acid, when it gets put in the aqueous solution, it releases H plus ions into the water, and then when a base gets put into an aqueous solution, it takes the H plus ions out of the water, so there's more OH. But I feel like I don't get it. Like I can tell you that, but I feel like I don't get it.
So it's really not that much more complicated than what you said, but okay, so there's, I don't remember, it's Arrhenius. Yeah, that's the other guy. It's the Arrhenius acid base, and then there's the Bronsted-Lowry. So they're just different ways of explaining what an acid is, but to be completely simple, it's exactly what you said. I mean, one is a proton donor, the other one's a proton acceptor, okay? So that's all it is. If you donate protons, right, then you're considered an acid. That's why water sometimes can be considered an acid, because when you have water and it splits up and it gives a hydrogen, like for example, water by itself, let's say you have a bunch of waters, but you just leave it by itself, it's gonna actually, one of the waters, how do I draw this?
Won't it be H3O plus H?
Right. So H3O, but then there's what is left over, right? What's left over is an OH. So that one, this hydrogen that was here in the OH got over here, was donated, right? So it donated a proton. So that means that whenever you donate protons, you're an acid. You're an acid. I guess, let me see of another way that I can explain it to you. But anyway, Bronsted-Lowry, because that's what you wanted to know. There's the different definition is Bronsted-Lowry describes the acid-base interactions as in terms of proton transfer, right? So that's exactly what I just said. It's in terms of proton transfer. So if a Bronsted-Lowry acid is any species that can donate a proton. That's what Bronsted-Lowry is. The Arrhenius one is a little bit more general, because I think what happened was that Bronsted-Lowry was very limiting, like the definition was very limiting. So they made another definition called the Arrhenius acid. Are you following me, or are you not following me?
Okay, I have another question based off of what you just said about the Bronsted being when you donate a proton. Never mind, I answered my own question in my head by saying that out loud. I was gonna ask about oxidation and reduction reactions, but those are the movement of electrons, not protons, so never mind.
Right. So an Arrhenius acid is any compound that ionizes to yield hydrogen ions. So it doesn't have to necessarily be,
when you say ionizes, you mean gains a charge, right?
right, it ionizes. So you either, yes, you gain a charge, and you gain a charge by releasing a hydrogen proton or something else. I didn't really explain that correctly or nice and neatly, but your book does. Let's look at it. Your book has a nice definition, but they're both just different ways of explaining what an acid is, an acid and a base. They're proton donor, proton acceptor. That's it. That's all it is.
Okay.
Hold on. I didn't feel comfortable with that definition. I didn't like that. So let me go into your trusty book.
So that's why most
Yeah, so see, they don't go into much detail either. All they say is an acid can be described as a substance that yields hydrogen ions when dissolved in water. That's it.
Okay.
But that's exactly what I told you. And a base is a substance that yields hydroxide ions when dissolved in water. So you know what? Let's go, because Google.
Okay, I have another question.
Okay.
It was going back to what I asked earlier about the electrolytes and how you can tell someone's something's strong or weak. So like when you look at the solubility like rules on the table, it either tells you, well, except for like the one I asked about at the beginning of the hour, and it was like moderately soluble, it usually tells you like something is either soluble or it isn't. So when it's giving you the options of very strong, weak, or none at all, how do you answer that if the solubility table doesn't give you like an in between?
I'm not gonna give you a question like that.
Oh, okay.
The only reason you need the solubility chart is for the precipitation reactions, and I'm not gonna give you something that's not on the solubility chart so that you wouldn't know. I mean, there's no way I would do that.
Okay.
Yeah, no. I know because I've been around it for several times, and I like, for example, the organic compounds. I know their trend that they tend not to ionize, so therefore they're they're non-electrolytes. So I know all of that stuff, but I wouldn't expect you to know that since you haven't even talked about organic compounds. Like we really haven't, you know, that's not part of general chemistry one. So I wouldn't ask you that.
Okay.
Okay, so actually, hydroxide attacks and accepts the hydrogen from the hydronium. Lewis acid is the hydronium accepts the attacking electron pair. Oh, okay. Yeah, I'm gonna, wait, am I not sharing? Do you not see this on the screen?
I see the notebook.
Oh. Oops.
In this brief intermission, I tried to send it to you over Teams, but I had to zip it because it's a large file, so you have to unzip it before you can open it.
I'm talking about allows vet students, that's what she means by people who've been admitted into vet school, the opportunity to do a master's in veterinary sciences as non-thesis students. Otherwise, they have to do the traditional thesis option, veterinary sciences master's program, which does not allow you to take veterinary courses that can be used toward a degree in veterinary medicine. And as she indicated, for students who are wanting to do a master's degree as a preparation solely for veterinary school, that master's program as a non-thesis degree program can be completed in 1 calendar year.
I'm sorry about the back.
That's okay. So yeah, this is a good website for you guys. I'm gonna it really breaks down the two different types, the Arrhenius, the Bronsted-Lowry, and the Lewis. Hold on, I'm gonna copy and paste. Well, actually, let me just share. Why don't I just do that? That's smarter. So yeah, look. See this? And I'm not gonna, I mean, obviously this is a huge website here, but if you just look for leah4sci.com, this is like a really, I mean, it's long. We're not gonna read all of this, but it gives you examples and it tells you the difference. So one basically is one type of definition when you're describing an acid is based on electrons. Right? So an electron pair, it accepts an electron pair or it donates an electron pair. So we're not even there yet, right? That's like a little bit higher chemistry. And that's the Lewis. The Lewis acid is the one that does that, and Lewis base the opposite. What you guys were introduced to, which was basically the Bronsted-Lowry. And it's the simple, you know, I donate a proton, I'm an acid. I accept a proton, I'm, you know, I'm a base. So that's basically, this is a really good website though, or later on if you guys really want to look at it. But it's obviously the website is super long, so if you just put leah4sci.com, you'll find it.
As well as,
anyway.
That's why you really need to come and speak to me and we need to talk because
what would be expected to know gravimetric analysis?
Yeah.
Okay.
And then if you just say,
I mean, let me see. Gravimetric is basically, it's sort of like when you do the empirical formula type thing.
just the
And they
curriculum.
give percentages. And or actually were you like a question I could ask about a hydrate, right? So if I have copper sulfate heptahydrate and it undergoes a gravimetric analysis, it's basically I get a product, I weigh it, that's gravimetric analysis. So how much product you obtain, you can bring it back to whatever I'm asking you to.
You said how much product you would obtain from what?
So a gravimetric analysis experiment is basically a typical one is when you have like a hydrate.
Yeah,
right?
we did it.
Okay, right. So that's a gravimetric analysis type experiment. So I could turn that into a question of some sort. But yeah, do you need to know it? You need to know what that is. Yeah, absolutely.
So the question would be like the molecular, like where you give the molecular weight and we have the empirical formula and we find, or would it be something different? Like we're finding how many hydrates are attached to the.
Something like that. I like something. I like that. I like how many waters, depending on how much the difference in weight, how many waters.
So to find the number of waters, we would have to find the weight of the compound without the waters. The way we did it in class was we found the compound and then we converted it to moles and then we converted the number of water to moles and then we did a ratio of the water to the
compound.
To the compound, to the anhydrous salt.
Right.
And
So that way it'll give you a ratio and that's how many, that's the difference. So that ratio is how many waters it would have been attached to it.
And then that answer we just add, we multiply it by that. Like
Wait,
that
what?
gives you so like if the ratio was 4, then you know you'd have 4 hydrates.
Correct.
Okay. Is that going to be on exam 3 or chapters 3 and 4 exam or a different exam?
It could be. No, it could be on this next exam. Yeah.
Okay,
Yeah,
noted.
gravimetric analysis is chapter 3, right?
I don't think they talked about it in the book yet.
No, it's chapter 4.
Oh, it
I
is
haven't
chapter
gotten there
4?
then.
Okay, then yeah,
Yes.
no, it's free game. I haven't seen the I have Kaylin making some questions, so I'll see what questions she comes up with.
The reason I asked is because it wasn't on the study goals, but it was in the chapter.
It's not in the study goals?
No.
Then it's not on it. Then forget what I said. Then it's not on it. I thought, why is it not on it? Those study goals were made before me. So I just always assumed, hold on, I'm getting to the, yeah, 4.6, it's not on it? No way.
No, it goes from 4.5 and then it skips 4.6 to 4.7. So it skips gravimetric analysis and goes to acid-base titration.
That's ridiculous. That's very ridiculous. But I can't go back on my word. So if it's not on there, then no, it's not on there. So you don't have to worry about it, Chloe.
Okay, cool, great.
Not cool.
Cool
Not
for
cool.
me. I mean, I know how to do it because we did it for the lab,
Yeah.
but I would just have to practice doing it some more.
I'm glad you asked, Justin, because I probably, there's no reason why I wouldn't have made a question about gravimetric analysis because I thought it was on there.
No, I'm glad I asked too.
Okay, what else?
I have a question, but it's important.
ahead.
It's not really important, but it's just a question about convention. So usually compounds are written, with the exception of carbon, hydrogen, and oxygen, which are usually written in that order, but they're usually written in the order of electronegativity. So why is ammonium, why is it NH4 instead of H4 in?
Because the nitrogen is the dude that's actually attaching all of the hydrogens to him.
Okay.
Does that make sense?
Yes.
So for, when you write the H3, the convention least electronegative to most electronegative, usually you have the H at the front because it's only one H and then you go on with the rest of the compound. But NH4 ammonium is a bit of an anomaly because it's all H's are attached to him. So he's the center. So that's why I think they do it as NH4.
Okay.
Would it be wrong? I mean, it's not wrong, right? But it's a convention, like you said. So it would be looked at as weird. Like, what is that?
Okay.
Yeah.
And then this is just a comment. It doesn't really help anything with class.
Okay.
But did you see that they discovered black nitrogen?
I didn't see that.
Yeah, they had to go through a ridiculous amount of steps. It was like they had to cut diamonds and then put like 1,000,000 atmospheres, and then it was only there for like
A
a few
million
seconds.
atmospheres.
Yeah.
Well, I'm reading about it right now. Discovery of elusive black nitrogen structure finally solves. Highly conductive, which means could be used for oh, that's big. It could be used for semiconductors.
The irony is that it's not actually, it's clear, but it's
Right,
called
it's
black
not
nitrogen because of
black.
black phosphorus.
Hold on, let me share. Look, check it.
I don't know what y'all are talking about.
Cool chemistry stuff.
What?
So when it comes to putting the lighter elements of the periodic table under high pressure, nitrogen seems to be the odd one out, while oxygen, boron, and carbon all change structure. Yep, according to the pressure. Nitrogen does not. A glaring anomaly scientists have struggled to resolve. Let me see. Allotropes. We were surprisingly intrigued by the measurement data suddenly providing some characters of black phosphorus. Oh yeah, I'm gonna read this. This is cool.
Yeah.
Can you send that to her?
Can I send that to her?
I'm interested in that. Could you please send
Okay.
This is my teacher. Get your own chemistry
That
teacher.
sounds interesting though. I don't have chemistry, but I'm interested in.
Yes, it is very interesting. But yeah, no, I'm gonna read that. That's cool. No, I didn't know about that, Justin. It's awesome.
See?
Even though it wasn't on the, I don't think we covered it in chapter, maybe it was in chapter 2, but it wasn't on the exam. Will we be required to know allotropes, like the difference between
No,
diatomic
graphene and diamond, no.
and ozone?
No. I mean, the word, I'm probably not gonna introduce that word until later on. So you will see it. I think I talk about it when we do electronic configurations, but I'm not big on making you I mean, I'll tell you what an allotrope is, but are you required to know it? No.
Okay, I'm done with my questions that don't have anything to do with the class. Flo, you can go
Okay.
ahead.
I didn't get into the really hard precipitate forming questions yet. I only got like 4 done. So
I will say that next Thursday, I don't know if I'm having a study session.
why?
Dun, dun.
No.
You have to go to Atlanta.
Dr. T, no.
Yeah,
That's my time for last minute questions. No.
I know. So actually, Justin, yeah, it's Atlanta, but really it's because I got to get on a plane to go somewhere.
Well, we can move the time.
Well, and that's what I think I might be able to still do it. I think I might have landed by the time it's 7 here, because I'm gonna land 7:30, which is really 6:30 where you guys are at. So I might be able to
take off late.
just do it on Tuesday. What do you mean do it on Tuesday?
No. It's gotta be Thursday. Please. Because I have a test on Monday and Tuesday, so I can't really sit down and look at everything until Wednesday. So I was going to give you all my questions on Thursday.
So I'm okay with doing it. Just might not be exactly at 7.
That's okay. We don't go to bed. We're college students. That's fine.
I go to bed. Sleep is important.
Well, I don't go to bed, and I assume you're not going to have it at like 3 a.m., so I can move it to 8.
No. So if anything, I'm planning on it, because my husband's gonna be driving, because once we get off the plane, we got to drive. So during that driving period, it's gonna be dark. I don't know how I'm gonna do it, but in the car, I guess I'll try to answer your questions.
Okay. It's okay. We can do the writing for you. I'll write what you say.
Uh-huh. Right.
Yeah.
Okay. But do not be super pissed off if it's not as helpful or if it's shorter or because I'm gonna be in the car. It's gonna be difficult.
Okay.
But anyway, yeah. So and I think it'll be great if it's just you two because it's easy. But yeah. So that's that. Any other questions? We have 4 minutes. You want to ask something or no?
It'll probably be more than just us two
Yeah.
It's not a question,
because
but
it's the day before the test.
it's
Yeah.
just a comment. The
Mhm.
free book, even though it's not the book, there are on OpenStax, there are reading guides for all the chapters that have practice questions and samples. And I find, like, I understand both books, but the free book is slightly easier to understand because the wording is not as wooden. So I usually do the free book questions, then I go to the regular book questions because it's the same material, but it's presented in a better way, at least to me, in the free book.
That's cool. I didn't know that. So it has like guides too. It has like a study
Yeah,
guide.
I'll put the link in the chat. It has it for all the chapters. Like,
Well, it's
for
the
one of
same
them,
link, right? It's the same link as the one that I gave you, or no?
so it was like OpenStax chemistry, and then it had like resources for online learning, and then it has like reading guides for like all
Oh,
the concepts.
okay. Yeah, yeah. Send me that, and I'll put that in the syllabus. I didn't even know they had that.
Can we see your cats? I know that's not a chemistry question.
Yeah. Hold on. Gordo, you're being summoned.
His name's Gordo.
Gordo?
Yeah.
Oh, cute, man.
Oh, look at the cat.
Well, he's like, what's happening?
And it's like almost the same one as on my screen.
Oh,
Oh, do you have more than one cat?
Yeah, I do, but where's Kuchuchi?
so what's the name?
What?
He said, what's the other cat's name?
Well, her name is Química, which is Spanish for chemistry.
Oh.
But I call her nickname because like that's not his name is not Gordo. His name is Suarez, but his his name that we call him is
Oh.
because he's a fatso. And the other one is Kuchuchi. I don't know why. It just evolved into Kuchuchi. Hold on, let me see if I can get her. But then it's 7. But yeah, I still have 2 minutes. Hold on, let me see if I can find her.
Oh, he's so nice.
What, the cats?
I'm your teacher.
Yeah, I've been failing her exams though.
If only you could see. You could probably guess the face I made.
She cannot find the cat. There's a missing cat.
The cat is gone. Hopefully not.
She's probably hiding. Cats be like no human interaction at the moment. Come back during my office hours.
Maybe for food later.
Okay.
The other cat is here. Oh,
Where? Oh, that's Kucha. She was sleeping, poor baby. She was like,
oh,
what?
I feel bad for waking her up. Okay, I just really wanted to see them because I can hear them in the background sometimes.
Yeah, that's Gordo. Because he's always crying that he needs more food.
But that was all my questions for today. You answered all of them.
Awesome. I'm glad. Wait, Justin, what did you put in the chat?
Yeah, I put the link
Oh,
to
the
the
thing. Okay, perfect.
yeah.
Perfect.
I can share my screen like really quickly. It's like just to show all the different parts of it. It'll take like 10
Go.
seconds.
Yeah, go.
Can you see my screen?
Yep.
Okay, let me try to hide this on the
Oh,
side.
it's an OER Commons. That's nice.
Yeah,
Awesome.
and then it has it on atoms, and then it has it on what we're on right now, stoichiometry, and it has it by different sections. And I usually do all these before I try any of the problems because they're simple, but they get the job done. And then I'm not sure if we're moving on to thermochemistry for chapter 5, but it has that too.
No, that's chapter 6, actually. Thermochemistry is chapter 6.
Oh.
Chapter 5 is just gases and gas laws. So you're chapter 9. Yep.
Yeah.
Okay,
I
cool.
usually do these.
Cool. I'm gonna put this link then on the syllabus because that's helpful. All right.
Thanks, Jess.
Thank you guys.
All right.
All
Bye,
right.
Dr. T.
Bye, darling. Bye, guys. See ya.